Yo, yo, yo. What's up, everybody? Welcome back. Today, we are trying to run Zig on a Raspberry Pi Pico. I don't really feel like I need to explain my motivation right here. It's fun, and I want to. I have a Raspberry Pi Pico for some reason, and I want to run Zig on it, okay? Screw using their SDK, screw doing whatever we're supposed to do. I just want to see if it's possible. And so, we've been working on kind of getting like booting up for a little bit. So we have a boot loader here that should kind of work. The way that like the Raspberry Pi Pico boot process works is like they have kind of a some read only memory that's sitting on the flash uh, of like I guess the SoC system on a chip. He has some like hard coded stuff on him that basically says like he does some other stuff, but for our purpose, we're gonna say he looks at Flash. He says, "Is there bootloader 2? Yes. Okay, run it." Right. So bootloader 2 is kind of like we have like on Flash. We kind of have like our bootloader, which is kind of custom per executable, where executable is kind of like the only thing that is on the program, and then this is just kind of like everything else, the rest. And we have the world's worst proof of concept of this guy, right? So he basically says, in a few more words, take the part of the executable that I want to run, put it in RAM at the beginning of RAM, and then jump to the start. And so from there, we should be able to do anything we want. Now we're like running normal code. So here we should have an example of that working, I think. Let's see what this does. If I hit continue on here, we are in our start function. Okay, yeah. So we have a crt0.s that does nothing really much except for say, make me some fucking code, start a breakpoint, put 100 in register 0, and then add to it forever. So if we run that shit, we continue, we hit our breakpoint, and we just keep like slapping next instruction a little bit, and we see it kind of doing our little assembly loop, right? And if we do like a like info registers are 0, we see it's 16, and then we go like next instruction a couple times. 117, wow, it went up by 1, crazy. And so I think today's plan of action is to figure out how to like run Zig without support for an operating system. I think it's possible, but maybe doing it on our desktop first might give us a little bit of an in that's a little less confusing. Then we can try to figure out how to like parameterize this stuff and run it on the microcontroller, and then maybe if that goes quickly, we can try to get serial up and running and like maybe hook up to Zig's logging infrastructure so that we have like the typical stood log warn, and that like shows up on the serial port or something. That'd be kind of cool. Would be kind of cool. And I guess let's just get moving. Okay. So, how the fuck do we run Zig with no OS support? I don't know. Let's make a little main function, I guess. Main Zig, pub function main. And I guess maybe we'll do our typical like return error hello to make sure that something happens. Right? So we like Zig run main Zig. He's gonna be like, uh-oh. Oh, sorry, error hello. I forgot. I said hello this time, not uh-oh. And probably we want to want to have some sort of like custom build associated with this thing. So we say import the standard library. Here's our builder. Our builder, we're gonna like add some executable, and he's gonna have some name of test, and his root source file is gonna be like relative to the root of the source directory. We're gonna be like main.zig, I guess. And we usually have to say that he has some target. Boom. And optimize standard optimize option. Okay, so we say Here you go. Optimize is optimized. Okay. And then we say, could you please install this thing? Install artifact? Yeah. Okay. So we run zig build. He creates some stuff. This stuff is so satisfying. Both the LD script and the bootloader with the macros are so clean and overviewable compared to the SDK. Yeah, I'm sure that will change over time. But yes, for now, it is kind of clean. I think that's like the typical, like the classic, we rewrote it and now it's better. It's like you rewrite it and now it's better because you're not doing all the stuff that they were doing before. And then eventually you like catch up and you're like, ah shit. Now it's ugly again. But we shall see. Okay. This guy prints hello. Now, really, he shouldn't know how to print hello, right? So there's something that like Zig knows that he's running on Linux, and I assume that this is a result of like the target triple. Like I think that he is auto-detecting that he is running on a Linux system. Clang target triples. I think that we can yeah, so I think you can like ask Zig to compile for any architecture for any OS. And I think you would do that with the standard target options of this dtarget. So I think we can like override our build. And we can say like x86-64 none, maybe, for like no OS. Maybe, no, he's mad. Operating systems, freestanding other. Linux is probably in here. So if we did like x86-64 Linux, that compiles and runs fine. So probably freestanding is what we want. Freestanding for, yo, we're like on our own shit. Don't fucking try to do anything. Which seems reasonable. He's like, I can't find the entry symbol start, which means that like the runtime initialization is not doing anything. So can we kind of hard code that? Can we go like kind of fuck your standard target options, but like, can we do target query, I think is what you do this. And here we're like arch os ABI is equal to x86-64 freestanding. Okay. Does that work? He wants a resolved target. He found a target query. So this is probably target query like this. We have to write try, and then it's like target is stood B resolved target query. Yeah. Okay. I think that's right. And then this -d target doesn't exist anymore, I think. Okay, we forgot to write that this thing can fail, so we just put a little exclamation mark to make the Zig compiler happy. Ooh, that's weird. I would have thought that this wouldn't compile. That's surprising. Zig built. Okay, I guess there was some like caching issues because now it's doing what I expect. Oh, interesting. Oh, it's only a warning. Oh, okay, so I guess it linked correctly, but the start symbol is not there, and so it doesn't know what to fucking do. Okay, so if we just go into main.zig and we're like, export function start, and we Zig build and run that, he segfaults. Can we do something like try to return 0 here? I assume that we can't, since we like have no OS, this shouldn't work, right? We shouldn't be able to go like import the standard library and do stood process exit 1, right? He should go like, I don't fucking know how to do that, right? Because he should be like, yeah, there's no member named exit here, which makes sense because he doesn't know how to do it. So we should be able to just like syscall. I think you usually do this in like assembly where you say, hey, operating system, could you please do some shit for me? So, Zig language reference. maybe is where I want to do this. And you can do some like inline assembly in here. I don't really remember how. Assembly? Here we go. Oh, look at that. They have syscall1 in what looks to be x86-64 assembly. So let's just copy paste that shit. And let's look up the syscall table, x86-64. And let's look for exit on here. Exit is 61 argument with the error code. So we should be able to call like syscall1 61 or something. And this should exit with an error code of 1. Okay, so that's good. We see 1 here, which is hype. Have you heard of the Zig embedded group on GitHub? No. But I don't really... I just kind of don't Google and start doing stuff. Okay, so this is good. We have a freestanding executable where we can execute a syscall, right? So I think this seems pretty reasonable if we call like main here. And we're in main, we're like int like const const x equals 10, and then we're like I guess we could say like catch error here. And if we catch an error, I guess we would normally syscall 1, what was it, 60 with 0, but we might call it with 1 here. That seems reasonable. So we're like, okay, in the normal case, we exit 0. If you error, we exit 1. And in here, then we're like, I don't know. I guess we just return an error and see what happens. And we get exit 1. Okay, cool. So I think I understand enough what we're supposed to do here, right? This is like world's simplest Zig setup, and it looks like it's not that hard. I expect that, like, if we... Do we have to, like, set up our stack pointer and stuff here? I don't really care, because I don't really want to learn how to set up the stack pointer on x86-64 right now. That's not really what I'm trying to do. But I'm curious to know if it is broken. How can we test that? It's hard because you need to, like, do a thing with side effects that Zig doesn't optimize it out, I think. Right, if I do this and then like maybe we pass this in here. Oopsies. I don't really know if it's getting optimized out and stuff, so it's kind of hard to tell. But fuck it. We'll say this is good enough for now. Let's try to make a ARM binary. You should get a working stack when the process starts. Don't need to do anything, I think. Okay, if you say so. If like the operating system might set that up for me. We're going to have to set that up ourselves on the microcontroller side, but whatever. Okay, so we're gonna want to be ARM freestanding, right? And we're probably gonna want to like respect the arguments that we've been passing in our other compilation script. So we're doing basically just CPU, mCPU, and mthumb. No start files is probably kind of implied here. And then we're probably going to want to have to figure out how to set up a linker script as well. So, first of all, does this build? Is ARM freestanding an appropriate name? Looks like yes, except for the fact that this syscall thing is like not allowed anymore because this is just like the wrong fucking architecture. So we're gonna have to come back to this, but otherwise, seems fine. And can we do like CPU features? No, I kind of want like the -m CPU flag. Is that a thing that we can kind of put on here? CPU model explicit here, whatever the fuck this is, surely. So that's CPU model. No, where the fuck? Hello, where was that? Oh, because this is a target query that we're making. So it's almost like we want the resolved target. We don't even want to do like a fancy schmancy thingamabob, right? Right? We just want to make one of these guys directly. Probably. So it should be more like CPU model equals explicit of Cortex M0 plus or something, whatever the fuck it's called. Yeah, Cortex M0 plus. It's with the dash here. Okay. What else? We have Arch is ARM. Okay. And then what happens when we do, like, how do we make it freestanding? Probably OS tag here? Yeah, OS tag. And then surely there's not really much else that we need here, right? Surely this is enough? I guess it was also, we need to get that M thumb in there somehow. Right? So where would that go? CPU features add? Maybe? Not sure how to get that. So let's just build for a second, just to see what happens. He's mad because expected type model found this shit. So does this need to be like... So we have to put name in here? And LVM name, I hope, gets figured out, and features we set to empty or something. I guess. I don't fucking know. Features equals empty, I think it was. Right? And LLVM name is null, probably. I don't fucking know, man. Let's see what that does. Oh, he wants to be a pointer. Looks similar to what they did here. CPU Arch. I see. Oh. Okay, and then this is cool too. Thank you. That's helpful. So, stood target ARM CPU Cortex M0 plus. Nice. That's kind of hype. That's nice. They've already done it for me. And then this is actually thumb here. I see. Okay. And then ABI, I don't think we really care. But maybe that's relevant. I guess we are technically EABI, so... Like, the rest of the code that we might call into, like, there's, like, boot ROM. There are functions in boot ROM that we might call into, and respecting their ABI is probably important, I guess. So, this seems reasonable. Seems reasonable. All right, cool. So that thing compiles, and I guess when we link it, we want to use our linker script, which must be a parameter on the executable. Is it something that we pass in on the options here? Linkage has a link mode. This is probably more like public and private, static dynamic or something. Sure. Strip, unwind tables, omit frame pointer. Do they, in this thing you linked, do they have linker script? They say elf set linker script path. Yeah, okay. Sure. Which, this looks old, right? 090, but maybe it's the same thing. Like exe set linker script path. Yeah, nice. Nice. Sure. And I guess that kind of means that this stuff comes up a level. I guess. Sure. This is probably going to fuck up, though, because we need to compile the assembly file boot2.s as well, right? He's like, oh, what the fuck? Oh, this is using ld.lld, which might have a different linker script format? Oof. Oof. LLD linker script. I did not consider that part. Okay. LD implements a large subset of the GNU LD linker script notation. The LLD implementation policy is to implement linker script features as they are documented in the LD manual. We consider a bug if the LLD implementation does not agree with the manual. But this is not complete. And it's a subset, right? So it's not everything. So I guess. Well, he is just kind of saying, like, throw a fucking comma in there, right? So we just didn't do that here, and I guess the other script allowed that shit. But this did not. Okay. So now he's pissed for a lot of reasons. So probably we're missing a bunch of sections in here, right? That would be my assumption. Right? Like we in our linker script are like we're taking out text, but I assume like the Zig executable has a lot more than just text. Right? That seems reasonable. Can we maybe actually not do any Zig stuff right now? And can we just only compile like assembly files and stick them in there? That'd be kind of interesting as like a first step there. So here he's like, we need one or more objects linked, sure. So can we do like add assembly file hype? So we add in our CRT0 and our boot2. And so now there's like no Zig in this thing, but it should be making what is effectively the same executable that we had when we were compiling manually, I think. Interesting. What's he mad about? So, invalid instruction. Any one volume would fix this. Instruction requires thumb 2. Okay. Oh, I think I did see somewhere that you can like specify thumb in here, and we're not doing that for some reason. Even though the CPU arches thumb, M thumb must not be getting passed to the assembler. Maybe. So can we say like I think I saw that somewhere in like their SDK. Maybe not. There's like M thumbs in there. Can we like find dot dash iname star dot s and then exec grep, something like thumb? Yeah, something like this, right? So they just write fucking dot thumb. Can we do that? If we're just like we're like thumb, Like, how does he feel about that? Not very happy. Okay. Operand must be in range. Okay, so he's like immediate mode move. requires thumb 2 to do immediate mode stuff. And it's not doing that. So, like, what the fuck? You know? Can we maybe zig build verbose and see what the fuck it's trying to do here to do the assembly? He's running build exe. Target thumb freestanding API. I wonder if we can, maybe we can get it to put m thumb on the command line somehow. You know, if we're like, like, is thumb a feature here? It is. So I wonder if here we go like Cortex and like we say like CPU model is, you know, this, and then we like throw on add feature. Like, can we do something like this? Thumb 2? I wonder. Seems like that's valid. Why is it mad? What if we do something that's like, you know, whatever the fuck this says. Where a feature set is like stood build, probably. This is in feature set functions? How the fuck does that work? Ah, I see. So we do something like, oh, this is public. So where is this defined? This is in stood target arm feature set. So this is like build target arm feature set. Yeah. And thumb 2. Here we go, baby. What even is thumb? Okay, so my understanding of this is that ARM has like 2 instruction sets. Like, it's like the way that the instructions are encoded into like binary, right? And my understanding is that thumb is like fixed width. Every instruction is 16 bits long. And for some reason that's better. Maybe for some reason. Maybe it's like more features. Maybe it's more efficient. Not really sure. I guess I want verbose. Target is not but. Is it just stood target? Oh, and then I guess I have to use my CPU model here. With these. Alright, let's try that. Let's try that. See what happens. Segmentation fault. Which means I would bet that maybe this has to be a static constant and he's not getting what he wants. That's my guess. So maybe this stuff kind of has to live here. Just a guess. If it's fixed width, it's much easier to parse. Yeah, that makes sense. CPU model is maybe here. What is this must be. This is a CPU model which lives in stood target query CPU model, of course. Why not shot? No field name. Oh yeah, I'm a dumbass. Stood target CPU model. Here we go. This has got to be the one. This has got to be the one. Still unhappy, huh? How do I get this to pass M thumb here? So I assume, let's actually like double check here. I assume that if I take this zig build command, right, and I run it, we get the same, fuck. We should get like the same. Yeah, we get the same thing, and then if I pass like M thumb here, unrecognized parameter. Oh, that's interesting. Yeah, okay. I see. So zig build exe thumb. Maybe this is not. Maybe we have to compile our assembly files separately. For now, maybe. Or can we do like ASM? Maybe we can like look up this error and try to figure out what's going on. So let's go back to doing whatever the fuck we were doing before, which was, this was like stood target CPU arm. It was like arm. Where was this before? What did we do? It was from here. Target arm CPU cortex. Here we go. Okay. Can we like add? I'm curious, like. B add object. I wonder if we could do something like this as well. I wonder if we could, like, if we add object, if we have the ability to pass specific options, depending on how he fucking does this, but probably not. Probably not. Okay. So I'm back to wanting to, I guess, just build this and look at the error that comes out. We've got a zig issue link. Oof. Oof. That's a bad bug. This is already planned. Sure. So FY for anyone affected by this. Implement sub-architecture translation in target Trimble. Okay. Passing the sub-architecture helps to enable instructions that would otherwise be disabled because the default for ARM Linux API is ARM v4t. Okay. What is sub-architecture then? What does that mean? What does it mean? Implement sub-architecture. So what does this do? LLVM subarch. And this is like just in their code gen. I see. So we're probably already there, which sucks. Okay, I wonder if we can just compile our assembly files by ourselves then. What other like workarounds were linked in that bug? I thought I saw some linked things that were like, oh sure. Um, what the hell? Oh, here, this is where we were. Okay, add workaround for assembling crypto instructions on ARM. What's their workaround? Do they have a good one? Uh, ah, they use X assembler. So we should be able to be like X assembler, and then they do M thumb like this. Did I spell it wrong? Yeah, where is this going? Did I spell it wrong? I might have. We might be. Yeah, okay, this is not the right place. Where is this going? This is like on some Zig command line, I assume. Raw, view file. Like, what is this part of? This is like filter linker arg. Oh, so maybe they're. Um. I mean, this could be old as well. Zig build exe help. Do they have -x args on here? Where do these come from? Where do these go? Hum 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 hum. Um. Can we just call like Zig CC? Maybe that's the play. That's probably yeah, that is probably what they're doing. Yeah, I see. So they're using Zig in that cargo Zig project is using Zig as the C compiler, I guess, to build C dependencies because Zig bundles like a fuck ton of cross compiler stuff. Sure. So maybe we manually do something like Zig C. Okay. So okay, what if we were to do something like this? We call instead of using arm on EA BI GCC, we call Zig CC, and we pass in a target here of our thumb freestanding question mark or something like that. Unknown CPU cortex. Is it? Yeah, underscore now. Okay. Promising. And then they were like, yo, we're not passing this shit through. So then we call X assembler. M thumb. Right, that was what their workaround was doing. But that doesn't seem to be working for us, which sucks. God damn, dude. Maybe we just go all the way to just doing this ourselves. Yeah. I mean, we could just compile this. Like, can we compile this with Clang? Just like fuck Zig CC? Let's kind of back out to there and just see what the fuck happens there. Clang. I guess Clang is fine. I don't know what version I want. I don't fucking care. Unknown platform. Okay. Like, how do I cross compile with Clang? Just assemble with AS? Yeah, I guess maybe as well. But I need like ARM non EABIs, right? So Clang assembler. Is that like a thing that exists? Which assembler does Clang use? LVM has its own integrated assembler and doesn't have a user-facing front end. Sure. So can we like, is it not thumb 2 as in -m thumb 2? But I mean, we could try that, but we didn't have to before, you know? Okay. So he is like, yo, M thumb 2, not allowed. So maybe this isn't. This might not be a Zig problem. I guess okay. Let's try cross compiling with Clang, because I'm pretty sure this is allowed. So Arch. Okay. So here we're like run with Clang. He goes like, yo, I don't know what the fuck we're talking about. Unknown platform, which means that this target is probably wrong. Like, should this be like an ARM none EABI or something? Unsupported argument Cortex M0 plus, so why? Can we look for like Clang, compile, Cortex? What's this guy saying? This is Clang. Shut the fuck up. Or GCC. Shut the fuck up. It was a dash before. I wonder if that changes anything. Oh, there we go. Okay, wait. We're getting somewhere. Unsupported option F0. Now what's happening? The fuck? I'm not passing this anywhere. There's also thumb non EABI. We could try that. Yeah, it seems like kind of equivalent. Okay, what is this? Unsupported option, this. We could just try upgrading Clang here. This is fun. Clang 18, This guy's saying this was fixed at some point, but also this is for x86. ARM. Can we say that? And then we're not supposed to prefix arguments with dashes because Google like fucking takes them out. I mean, we could just like throw like an F no on there, but I just don't really understand why we have to. We could just try turning it off. It's just weird that we have to. Just weird. Should be thumb V6M, but looks like it's picking that up. Oh yeah, that's a good point. Good point. Oh, actually, that might be interesting in terms of... we did see them talking about passing these things along better. So no, there's no thumb V6M in here. Okay, are we passing any like stupid arguments here that would like kind of force this to happen? Yeah, maybe, I mean, could try setting that? Yeah, I don't understand. Who is passing this shit? Like, nobody, I guess we're passing it now, but... but we're just like, yo, run some fucking assembly files, right? We're just like, make me some assembly. I wonder what happens if we do, like... something like this. True. We don't really want the linker script for just straight compiling. And it's interestingly only on one of these. So, which one? Oh no, it's just exiting immediately. I see. That's so strange. This guy's posting a thing on here. Clang, target, ARM none, EABI, CPU, Cortex M3, which is not the same as me, but whatever, it's close enough. mthumb, sysroot. Oh, I don't think I should have to provide a sysroot though, because I'm just asking it to like straight compile. And then, yeah, this does seem like similar to what I'm doing. Ugh! Why is everything so hard? I mean, I guess we can just compile with GCC and then link. I was kind of hoping to like use only Zig as part of the build, but I guess if it's just like kind of broken, it's broken. So what you gonna do? Okay, let's go back to our old command here. And can we do something like in our build Zig? Maybe here, not quite the old command. We probably want to do something that's like output boot2.o and crt0.o. Yeah. Okay, so we compile that. And then in build, we have these guys now. And then in our Zig build, we should be able to be like, add object file from build crt0.o and boot2.o. That should make us an elf. I think. Ignoring memory region for assignment for non-allocatable section boot2. What does that mean? What does that mean? Ignoring memory region assignment for non-allocatable region. I guess we can Google this. I've never seen this before. Can we look at like boot2.o here? So maybe whatever this guy is saying is like sections without alloc are a problem. So maybe we have to define that somehow. Section flags GNU AS or something. Yeah. So maybe that also solves some of the problems we were seeing before, where GCC doesn't like create the right he doesn't know that it's executable, and so that like causes problems. Maybe non-allocatable section. Okay. So A for allocatable. Okay, so now if we go and look at this thing, our boot2 is AX, which is hype. And then we run zig build here. Oh, okay. No linker output warnings. And in here now, we should have our executable as compiled by Zig has boot2 in here. And if we look at segments, promising. It's a little bit weirder. The physical address mappings are kind of like backwards, but it's like fine, probably. I think you can mark the whole region as executable in the memory part of the linker script. I think I did that, but I think he's not having it, right? I have this. Everything is executable. Oh, but maybe not allocatable. So sure, I don't know what that means, but like whatever. Whatever, we're getting close. Okay, so we have to run our patch elf script on this guy. So let's change our compile script here to be like, we're going to patch not build boot2.elf, but zig out bin boot test. Okay. And now we should be able to program this guy onto the flash, and it should just do what it was doing before, right? We haven't really changed much of anything. But maybe, right? So this is gonna run zig out bin test and zig out bin test. Okay. And if we run this guy, that's really promising. Oh. Hi! So we also, by marking that boot2 section as executable, we also fixed our debug info in the boot2 bootloader, which is kind of hype. Yeah. That's sick. Okay. Cool. So after all of that, we should have something that's like relatively sane. I'm curious now what happens if in our zig, we go back to like main here, and in here, we're just like while true. Does that like work? That'd be kind of sick. So fuck linking with CRT0 and add back in main.zig. That'd be kind of sick if that worked. I know I should just watch a YouTube video, but what did you do to patch the elf? We essentially just look up the boot. We in the linker script pad with zeros. Then we wrote a zig executable that parses the elf file and then CRCs the first 252 bytes and just overwrites the last 4 bytes in that section. Nothing too complicated. Why is this stuff trying to get into boot to RAM? I wonder if it's like something like the rest of the segments just go wherever the fuck we last asked it to. Yeah, okay. So that there's something to do with that. This guy's saying like, yo, we have the section text sub HF3, and he doesn't. Okay, can we ask for no zig runtime or something? Is that going to be allowed? Or maybe we need to turn on optimizations or something. If the zig runtime is just like not pruning itself correctly and just trying to shove it in there. I think there is like a throw everything else away syntax. Citation needed. More people in the world or on Twitch? Yeah, somebody's asking why people use Zig more than Rust on Twitch. I can tell you why I like using Zig more than Rust for myself right now. That's the only thing I can tell you. I can't tell you why other people do what they do. I used a lot of Rust. I think I programmed in Rust for like as my go-to language for like 10 years, probably from like this like early university until like even after I started streaming. Rust is great for some ideologies. I think that like I really like Rust if my programming model is that I want to have something that is impossible to use wrong at the cost of kind of like iteration time, right? So the like value prop of Rust from my perspective is that you spend more time writing your initial code but when you finish writing it, your chances of it being correct are significantly higher, like very high, right? When I write other languages, if I write Zig, I feel like take I can take more shortcuts while having still a lot of the safety guarantees from Rust over C, right? Like going from C to something better than C to Rust, it's like C is like so far down on the like safety scale, but C like Zig's kind of like more safe, more flexible, you know, in my mental model. And so like I was getting frustrated when using Rust because I would know that I wanted to try something. I didn't know if it would work out the way I wanted it to. And so I just want to try it. I'm willing to take shortcuts. Fuck it. I don't give a shit about thread safety right now. I don't give a shit about like multiple unit references. I don't give a shit. I just want to like try this thing and see if it like feels okay. And I just can't experiment that way in Rust. And so I find it frustrating to work in. Okay. But anyways, can we, as a temporary hack, let's just put this stuff on flash. We won't think about putting it in RAM. So now this succeeds, and we can take a look at what was generated. So, Jesus Christ. Holy shit, what is happening? I guess we just don't want the Zig runtime. Right, so Zig is like injecting a bunch of stuff that we don't want, I think. What happens if we do like compile with like OS or something? What's the Zig build? D optimize equals size or something? D optimize release small. Okay. Interesting. Oh, so there might be like link time optimization going on here. So we might have to explicitly say, don't fucking throw out this stuff, which was in there before, but we took it because we didn't understand it. Okay, so that's interesting. And if we look at this now, the segments are much smaller. So by turning, it looks like Zig is probably hucking the world at the linker, and then we should be asking the linker to prune stuff that it doesn't need. When you compile with F function sections, it creates a section for each function, which makes it easier for the linker to optimize away unused sections. That makes sense. You're missing the .text.star symbols. You only have text. But I think either way, I'm not really convinced that that's the problem. I'm not convinced that's the problem, right? Because let's go back here. So if we remove all restrictions from this guy, if we look at the segment info here, read elf segments of test. All of this extra shit, where is it going? It's all going into, it's following Flash, right? So it's just going wherever the last thing went, I think. And I think what's happening here is that all of this shit ends up being larger than we can fit in RAM. It's just like too much stuff, right? Because it's going all the way to 611F4. And so I think the thing that it was complaining about was it was like, we can't fucking fit that shit. So it would be nice. It'd be nice if like we could build in debug mode. But kind of like ask the linker to prune whatever it can. You know, whether or not we're in release small or whatever. So we have linker enable this, allow undefined, allow GC sections. Here we go. We probably want this. That would be my guess. So we want like link GC sections true. Garbage collect sections that are unused. And then can we go back to trying to put this in RAM? Let's see how that goes. Madfast, thanks for the prime. Oh, there we go. Hype. So we're still in debug mode now, but this thing is like a lot more sane, I think. Let's take a quick little peek skis. Let's look at the segments of this guy. So we do still have some of these segments. The executable still has definitely bloated a little bit. But it looks okay. Yeah. This is interesting. So it didn't manage to garbage collect these. I guess probably because I wonder if Zig has some like runtime shit that is like hard coded in there, like the stack unwinding stuff, right? Like on Panic, it might try to print some stuff, and maybe that's getting linked in. So that's kind of interesting, right? Our size of this thing is like, that's huge. But fuck it for now. We can come back to this. I expect that we're gonna have to try to do some pruning of this stuff later. But for now, we just let it go, I think. What's over here? Oh, this is bad. This is not good. We probably want like to slap. We need to make sure that like physical address of 2000, this won't get put in the binary. Like this won't get like programmed to Flash, which means that we actually do need to specify everything we care about. So somebody said try a linker script thing that had search for everything. I'm trying to figure out where that shit was. It was like We wanted dot text and dot text dot star. You're saying that like it like regex is or whatever. Let's see how that goes. Compile, and then we can do read elf segments of zig out bin this. Looks like software math ops. It generates those of the ABI, so it doesn't have floating point support. Yeah, it makes sense. Okay, so now it looks like that did something. We still have RO data to do, and like I don't know what arm exidx is. Exception table? Maybe? What is this? Table routine of start addresses, a pro counter. Or can't unwind. Yeah, okay. So can we like disable this shit? I don't really want it if we can get unwind. Like, I know that there's something about unwinding. Sounds familiar. Stack size, want LTO. Error limit, blah, blah, blah. No built-in? What's this? F no built-in? F no. F built-in. Enable implicit built-in knowledge of functions. Oh, sure. I see. That's not what we want. Just throw it away in the linker script? Yeah, I guess we could. Yeah, fuck it, I guess, right? If we're like, we don't think we need it, we're just like, get the fuck, anything that starts with like arm, we're just like, get it the fuck out of there. That seems kind of funny. Yeah, that's pretty funny. And now we have RO data, which we can put in Ramit Flash. Right? And we probably want RO data flash start, probably, and flash end. I guess we actually want sizes here. These are better names. So we want text size, RO data flash start, RO data flash, RO data size. And then here we're like RO data like this. And then we also want the virtual address start. So this is like here. Right? I think it's like this. You'll have to handle data in PSS eventually. Yeah, but we don't have to right now. Right? So we can just cheat. Okay. So now we should be able to be like in our boot 2. We want to make sure that we're copying RO data to where it's supposed to go as well. So first of all, we have text size now, not text end, which should make our lives easier. So this is like we put text size in the argument 2 to memcopy, and I guess we're probably going to do this again, right? So we're going to be like, we're going to copy into RO data start from RO data flash start with RO data size. Wait, which means that these things are not used. I think that works. That looks promising. Executable RO data. Let's go! Yeah, we're going insecure as fuck, dude. And writable RO data. Yeah, fuck it. Not that like this processor has NX bits or anything. I don't know. I haven't checked. But yeah. Okay. So this looks good. right? This looks very good. So we have 3 segments that are going to be copied onto Flash by the OpenOCD programmer. They're going to live at, address 1000, 1100, and then like whatever, wherever the fuck the program ends. And the virtual addresses of these guys line up. Right, so and we're gonna hope to God that our programmer will like copy these into the right sections now. And so let's just try it. Let's see what happens. Okay, so something's happening if I hit break here. Not looking great. Okay, let's set some breakpoints in here. Like maybe in boot 2, let's maybe breakpoint here. Right before we jump to start. And try to step by instruction and see what happens there. Compile. Oops, compile and run GDB. So this programming is taking fucking forever, which is sick. I guess because we were uploading just like too much shit. I guess. Okay, so we hit the breakpoint, so that's good, right? And we look at start, and that's at some address, and if we jump into that thing, so it thinks that we're there, which is good. But then it looks like it crashed, maybe? That's kind of my guess. That's my guess. Is that when I tried to jump over next instruction, he goes, target not halted. So maybe does anything here? Monitor, reset. Let's see. Continue. Maybe it'd be interesting to disassemble there. Maybe what we've assembled from Zigland is not okay. Okay, disassemble. So here we're just like branch to my fucking self, baby. Which seems fine, unless this is an immediate. If this is like a non-relative address, I wonder. No, because branch is supposed to be relative only. So I actually don't see the problem with this. I'd be interested to replace this with a CRT 0 that does the same thing. Because this is not behaving the way that I would expect. So if we do the exact same thing, right, where we do this, just like literally just do fucking nothing. I guess it was technically like more like this, where he's like start, branch to the next instruction, and then branch forever, right? That's kind of the disassembly we saw here. 2 instructions, right? I'm curious to see if this does something similar. So we're like, fuck your Zig shit. Just run my bad boy. I guess it's also possible that like the memory got corrupted and we didn't copy it like we thought, and we were disassembling based off of the debug info in the ELF, not what was actually on Flash. I also don't understand why it's taking so long, but it's fine, it's fine. Okay. So, step instruction. Boom. We're still in main.zig? That doesn't seem right. Compile. This doesn't seem right to me. I think that there's probably a caching bug if there's no root source file. That's my guess. That's my guess. Okay, let's try this. Compile and GDB. Okay. So run the same thing. We go here, and now we have the same thing, right? Very similar, where we're like jump forward on the first instruction, then branch forever. So this is fine, right? So that's a sign. I wonder if the amount of shit that we're putting into the executable is just so much shit that maybe our like stack pointer is colliding with the code and like we're clobbering ourselves. That seems possible because our stack pointer is like at the top of memory, and then we just programmed like whatever the fuck we wanted here. And if this stuff is going like overwriting, then we could get into trouble. Why is the code starting calling start +1? Because the bottom bit in the thumb branch instruction picks the instruction set, right? So we were saying earlier that in ARM you have both thumb and like normal ARM instruction sets. So the one says be thumb, please. Madfest, thank you for the prime. Sorry, I missed that 14 minutes ago. But much appreciated. Okay. So I would be interested maybe the next thing here. Are you setting the stack pointer? It's set on boot to be just a little bit under. Okay, we'll bootloader stage 1 sets it. So here is like RAM. Bootloader stage 1 programs boot stage 2 into the very, very top of RAM and then sets the stack pointer here. And then we, in boot stage 2, copy like executable into here from bottom up, right? And it's like, maybe these are colliding. It's a possibility. We could check in the debugger, or we could just build with release small and see if that improves things at all. Compile. De-optimize release small. Let's just see what that does. So now, God, that's so much fucking better. Wait. There's no way that's right. There's no way that's right. What the fuck? Right? Unless I didn't save the build.zig. I guess maybe it is right. Let's see. Okay, interesting. It seems like he's not running my code now. Why the fuck not? We should be at least getting into boot too. The fuck? Yeah, okay, so we go optimize, release, save, small. That seems correct to me. Objdump -d on zig out bin test. Oh, sure. Arm none EABI objdump. Here we go. So he's got the boot 2 shit, and then his text section is, oh, broken as fuck. That is interesting. So that's probably why the processor's crashing and resetting, because Zig has thrown out just something that the compiler doesn't understand, or that the CPU doesn't understand. Which probably means that we've done something fucking stupid here. I don't know what, but let's just like twiddle buttons until we figure it out. Yeah, this is strange. This is strange. So in the optimization process, he's just spit out an instruction that he's just like, what the fuck is that? Actually, this feels fucked up too. Maybe the obj dump is wrong. Maybe I'm supposed to write like m thumb here. Yeah, maybe here. Maybe I'm a dumbass. Ah, there we go. Okay, so maybe it is fine. Here we go. This makes more sense. So now we have our boot 2 code that looks relatively correct. Then we have the text section here, which is literally just, oh. Oh yeah, he's like branch forever, back to myself. And then like, theoretically, I guess I might return, which should never happen. So this seems fine. This seems fine. Text section really small, loaded at 2000. The segments here line up, so we're like, take the shit, put it at 2000. It's only 4 bytes long. Okay, and then in our boot2.s, we set a breakpoint even before getting there, so I really see nothing that should be wrong here. Really, I don't see anything wrong here, so curious to know what the problem here is. Okay, so disassemble. It's confusing to me that this looks different. I will say that looks different, right? We saw in objdump that it was supposed to have a branch instruction below this. That's concerning. Disassemble main.start plus 16. Start plus 16. Yeah, why does this look different? That seems bad. I'll say it. Right? Oh, wait, this looks different again. Maybe I'm fucking high. Is it not supposed to be garbage collecting the sections now? What the fuck is going on? Maybe I didn't run compile.sh here. There we go. Okay, maybe I fucked something up there. That's very possible. Let's try that again. Okay, so here, disassemble this plus 10. Here we go. So, oh, maybe I'm supposed to go -1, not +1. Maybe I branched. That's kind of funny. Or maybe the start symbol already had the right address now. That's probably more likely it. So before, our start address was set at 2000, and then that person was asking why the fuck did we plus 1? I think that they kind of were on the right track there, and that we shouldn't plus 1. This should be or 1, right? Because if it's already set, we don't want to increment it. And I bet you that's what's happening. He doesn't like that. So let's just do it manually for now. We'll say load the register with start, and then can we do like bitwise, or where's like that RP2040 datasheet that tells us what all the commands are? Assembly, or it was like under like the part where they talk about here somewhere. Okay. Add, subtract, multiply, compare, logical ors. Can I do ors with an immediate? No, they need it to be registers. Fine. Move R1, 1. Okay. Let's try that. So this says, take start, or it with 1, or move R1, number 1, ors R1 and R0 into R0, and then branch to R0. That feels like, really? What's he pissed about? It's 2 R's, not 2 O's. Ors. The fuck? What do you mean? Fine. We'll just look at this then. Fine. Isn't this just fine? Am I fucking mental? Maybe it's redundant? Dude, what the fuck are you talking about? Ors not supported are thumb 16. Am I fucking stupid? This isn't even the right thing. Ors are thumb 16. Maybe we'll ask the idiot. Not that he ever gives us the right answer, but why? Fuck you. ARM V6, Cortex M0 plus ARM assembly. He doesn't like ors when compiled with thumb, with M thumb. How am I supposed to bitwise or? Question mark. God, what an asshole. You're such a dumbass, such a dumb fucking piece of shit. And it's like, this is what I'm fucking doing? You fucking dumb piece of shit. He's never helpful. He never tells me the right answer. This is very shocking to me. Just out of curiosity, yeah, okay. Thumb 16 instructions. Like, we download this reference card and we just see it. It's right here. It's right here. So just to be clear, what if we try to do something less like add registers low or all registers low? So adds are DRN If we did this, that's not allowed either? Like, what is he fucking talking about? But I can... Is it just like anything? No, that's a bad instruction. I wonder if we have to do like add lower half or something. Like if there's like specifiers for like half word, no. Does thumb just not have math? Did the idiot say ors instead of or? Oh, maybe. Oh, good fucking eye. What the fuck is the difference there? Or versus ors ASM. What does it mean? The or and ors instruction. Or shift. I'm just a dumbass. So these guys are just fucking with me. They just want me to hate my life. Got it. Fine. Maybe this is like a syntax problem. Maybe like, because when I was looking at the disassembly in GDB, it looked different, right? Even like obj dump here. Right, we're seeing ors here, which is not what we typed. So I wonder if it's like Intel versus AT&T syntax or something is just like fucking me. To try using an intermediate with or, just curious. Yeah. Me too. Me too. Unshifted register required. Okay. Fuck it. Very strange. Okay. Okay. So that was probably it. That was probably it. So if we compile and run and we hit continue, breakpoint's not happening? That's fucking weird. Oh no, wait, the breakpoint already hit. My bad. So we go here. We disassemble this plus 10 or something. So we're right here. And can we look at what is stored in program counter plus 40? So print this plus 40. I wonder if this is hex 40. I guess we can just look at what's in the register 0. That's probably easier. Info registers. Yeah, so R0, the start symbol automatically gets the thumb instruction set bit. Interesting. Do you have dot syntax at the top of the ASM file? Probably not. I see. So maybe I'm supposed to use unified syntax? For ARM instructions, the conditional affix always appear at the end of the instruction. For thumb instructions, the conditional affix can be used, but only inside the scope of it. Yeah, I don't know. All instructions set the flags, even only if they have an S affix. Okay. Yeah, I don't know. I don't know. Okay, sure. But that's more reasonable now. So we are actually in Zig, right? I think. We've seemed to have lost our debug info. Because we built in release. But I am confident that we are in Zigland. So I'm curious now, can we go back to building in debug mode? I know that the programming took a long time, but I'm curious now to see if it still falls over in the same way. Because we were just branching to the wrong fucking spot. We were just not going where we wanted to go, and maybe that was causing problems. All right. I think we're in. I think we are in, dude. So let's try to do like something a little bit more complex. Can we do something that's like, I don't know, const text equals hello, right? And can we go like while true for text, character, can we like just do something with that character? I don't know. Maybe we call like main with that character just to like make something happen. And we can do something that's like if this thing errors, we can breakpoint. Yeah. And then in main, we'll take in a character, and then we will just say if C equals E, return error, or something, right? Like, let's just see what happens. GDB. Blink LED. Yeah, that would be nice. But I want to start small. So it looks like he crashed. It does look like he crashed. So maybe breakpoint here, and we can try to step through what he didn't like there. Because he didn't like something. Okay. So we're going. Can we info registers here? Who knows, man? Okay, so we go to main. Okay, so we go into main with the number 1 here. That doesn't look good. Right? We can think that that doesn't look great. Right? So why? It could be that we didn't copy everything where it's supposed to go. That seems kind of likely. Seems likely. RO data's in there. But I guess maybe we shouldn't discard everything else. Can we like strings on zigout or nm-c zigout bin test.elf? Oh, this probably isn't. We have main.text here at 30bb8. The fuck? Hold on. We have breakpoint here, so we should hit this breakpoint. I wonder for like watchdog resetting? Maybe that's a possibility. Like, is the text in here? That doesn't look right to me. Hold on. Yeah, so here. Yeah, this is where it thinks it is. Although this could be the fat pointer. I guess it could be. So we could try doing this, whatever the fuck this guy is. Oh wait, yeah, that looks like it. Okay, so hello does seem to have made it into the binary. We've copied it to the right spot. He understands himself. And so then I guess we should just see where we fall over. Looks like maybe here. Oh, I see. Are we just at the breakpoint and it doesn't know how to deal with that? Yeah, maybe. Maybe. Okay. Next instruction? Can you not next instruction over breakpoint? Oh, I see. You have to continue and then next. Okay. So H, E, breakpoint. Then we have to hit continue. L, L, O, loop again. So what's interesting to me is it's like it's kind of working inconsistently. What happens if we take the breakpoints out of here? Maybe. Like, just kind of confusing. So it looks like I am just kind of in that loop. So maybe it's fine. Maybe. Seems kind of okay. Yeah, fuck it. Okay. Maybe when it was dying, there was just like a mistake somewhere that I didn't notice. Like in like the compilation process. Okay. So maybe we can try to blink the LED. I was gonna do serial, but I think blinking the LED is like an easier thing to get in the next, 30 minutes. So we have this C file. And maybe even for now, just to make things simple. I don't really want to do this all in Zig right this second. I just want to see if this kind of works. Right? So we can just export all of these functions and run the main loop from Zigland. I think that's going to be my play. So here we can go like main start, we just call main, and I guess like main, and we do like catch unreachable or something. I don't know how it's gonna like handle panics, but we will see. And then here we'll go like C dot C dot C dot C dot here. And I wonder if we can get away with like C import. I wonder if we can like just raw C include this like C file. That'd be kind of hype. That'd be kind of hype. All right, so there's a lot to think about here. Okay, fuck it. Blink.h. And then we do maybe a, oh, well, I guess first we say, can you add include path of, just the root of this guy? Fuck it. Let's see how he feels about that. Okay, so incompatible types. Yeah, okay, so he doesn't like this. Fuck it. Okay, so we'll add C source file of blink.c. Is that all he wants? He wants like a, I think he wants something a little bit more intelligent than this. He wants like file equals like this, and then we have to make a blink.h. that has the interesting parts. This and LED in it. And Sphera, wait. Which where it was here. And then we need to do our, this shit. And then I think it should be fine. We'll see. We will see what he complains about. Okay, so why is this happening? Architecture ARM v6m does not support ARM instruction mode. This must be coming from like the C import, right? Now he's just, oh, right. Can we do like a little zig translate C? What if we do like the translate C part manually? B add translate C. Let's just see. Target is target. Optimize is optimize. Root source file is B path blink.h. And we'll say blink header is this, and then it's like exe add root module add import or something, and it's like blink is blink header module, something like this. Then in here we're like const c is equal to import blink. Okay, and let's see how he feels about that. Let's see how he feels. Same shit, but okay. So that must have to do with like this add c source file blink.c, right? I assume that if we take this out, we don't try to compile blink.c. I assume that this will work, but then fail to link because those functions don't exist. No, not quite. I don't know why the fuck that returned something, but we will trust it. Yeah, okay. And this is probably the same shit where like the C files are not getting all of the arguments they're supposed to get, right? That seems likely, right? So can we just be like flags equals m thumb or something? Like, is it something like that? He says like ARM instruction set not supported. So if we force it into thumb by passing an extra flag to the compiler, okay, cool. Promising, promising. Delete main from this bad boy. And libc not available. Why does it matter? Why do we care? I guess maybe we're like no start files or something. Like just get it the fuck. Or like without no stdlib. Like just get it the fuck out of there. Um, maybe you need libc to link C source files? That's annoying. That's annoying. You use spec2, gnosis.spec or nano.spec? Yeah, maybe. We can try it. I don't really think... I suspect that's not it, but he has gnosis. I don't think I did... Oh, I mean, gnosis is the one I'm supposed to use. I see. Yeah, exe link like libc. What does this do? Like, is it something stupid? Like, this is getting set to true if there's a C source file automatically in there or something? Even then, like, why? Who? Oh, that's so annoying. Okay, I mean, I guess, I mean, we were trying to save time by doing this, and I guess maybe that's just not the play. Maybe we just run that shit back in Zigland. I just don't want to right now. That's the only problem, is I don't want to. Because it's a non-zero amount of work. But I guess we must. We must. We have to. We don't have a choice. Okay. So const LED delay milliseconds 250. Boom. Const SIO base is this. Okay. Boom. Const GPIO SIO GPIO. I guess we can kind of do something like macro this probably. What's he mad about? Like if we go here, we comment out everything of relevance here. Oops. He gets happy again, right? Yeah, okay, he's chilling. He's chilling. Okay. So we do like const here, delete till underscore, lowercase, forwards equals, semicolon. I think I fucked that up. Delete word, const, delete to this, lowercase, and equals, semicolon. Boom, 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 boom. Okay. He's mad about all this volatile void shit, which is fair. Okay, so this is like, we'll figure this out later. This is a function, I guess. Try freestanding. I'm already over it. I'm already over it. Function pad GPIO adder given some num, which is a U8 or something. We return a volatile U32 star. And it's just like we are returning this. Okay. How do I do? Is it like this? Yeah, there we go. Nice. And then num is like this. Boom. And then this is like this. All right. Cool. We'll figure out the rest later. Function IO bank 0 GPIO control takes in U8, returns volatile U32 pointer. Sure, fuck it. And that's just like the shit over here. Sure, fuck it. I don't know, man. Timer base is this. Timer HR. We'll do like the pointer casting later. Okay, RSOC base. That's this. Boom, boom, bum, 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 bum. Okay, we're getting closer. Okay. Sphero, wait. This is for 0 to this number. We look at the pointer of this thing. So this is RSOC count is RSOC count. This is like as a volatile U32 is a pointer from int of this. Boom. Boom. Okay, so that's Sphero weight. Done. And I guess this is even enough, probably, to test that we're on the right path. So this is using some timer. What's he pissed about? Invalid left-hand assignment? Why? I guess we'll find out. So yeah, let's try this for a second. This should be enough to test if we're like interacting with hardware correctly. What is the invalid left-hand assignment? Maybe you need like, oh right, it's this in this language. I'm a dumbass. I'm a dumbass. All right. So now he's mad because we didn't fix the build.zig earlier, so fuck all this blink.c shit. And I wonder if we're supposed to take the RSOC out of reset. I don't think so. I don't think so. So let's just see if this like kind of does something. So he's running. And I mean, it's hard to I guess it's hard to tell if it's working, but I think it is. I think. Let's try to initialize the LED, I guess, and we'll kind of see where that ends up. Okay, so we have some LED pin. And let's try to do our LED initialization. If the LED turns on, we're fucking golden. So, Pico LED in it. Boom. Takes nothing, returns void. We do some shit. So probably we want to go like reg from address. This is probably the easiest way to handle this for now. This is not the way that I would really want to do this, but it's the easiest way to you know, to handle this for now. So here we're like reg from address of IO bank GPIO control. Oh, which we already returned a volatile U32, so we're actually kind of chilling there. So we're like, let's get the initial function select from this guy. Then we reg from address of reset base plus hex 3000 is equal to this shit. Then we're like initial reset is reg from address of reset. Okay, seems fine. Then we write to something here. So we're like, reg from address of this shit is equal to this shit. Okay, so this is SIO base now. And this, boom, okay. Reg from address this. Equals this. That's what we were doing before. Okay. And this is now get rid of these Pharaoh prefixes, lowercase it, and bam. Okay, set the multifunctions shit, so IO. Why did we use this? This didn't ever come into play. We just kind of hard code it to 5. Okay, cool. That makes sense, I guess. By some metric of makes sense. And then here we're like, this does nothing. This does nothing, so we take this out. Okay, we're close. Okay. Pipe. Initial reset also not used, surprisingly. Yeah, I guess that's just unused code. Okay, cool. So this is really all we need to do to Pico LED in it. So let's take a little peek skis. So we're hoping to see that the LED is in on. Because this is the set. So we're saying enable output. So here we're like, take the SIO out of reset. This is like turn on output on this LED, then set the output to 1, and then use it as a GPIO. That's what that's supposed to do. Let's see if it happens. 20. We'll just take U32s here, and that'll make our lives easier. Oh, then we also need this to be like pointer from int. Boom. All right, let's see what happens. Fingers crossed. Oh, baby! LED turned on. Can we... Look, can we see it? Can we see it? It's fucking right there. It's on. Trust me. You're gonna have to trust me. You're gonna have to trust me. But it fucking worked. So... pretty sick. Pretty sick, if I do say so myself. So that means that we're pretty close, probably, to being able to, like, blink the motherfucker. Probably. So let's just do that and then call it a day. So this is on bool. Blink the motherfucker, yeah. So if on, we should be like reg from address of this and this is equal to this. Yeah. And in reality, this only works for... This will clear all other GPIOs, but fuck it. And then in terms of sleep, we have Sphero wait already, so sleep is not relevant. All right. Let's fucking hope for the best here. And transition. Is it blinking? I see no blinking happening. I'm not gonna lie. The LED is just on. So you kept the same line. I probably did, huh? Yeah. Yeah. we do need to do, if we want it to blink, we do have to make it blink. If we want it to blink, we want it to blink. Okay, give it a sec to program. He's working hard. Bad news bears. Not blinking. Not blinking. Bad news bears. But we can start looking at why. This seems relevant. Okay, let's change this to 1. And let's just see if we ever get out of there. Because I seem to remember having to do some sort of initialization of the clock. Okay, that's good. I just saw the LED turn off. On, off, on, off. So I'm actually seeing that shit toggle. Off, on. Which I don't know if you guys can see. There it is. There it is. So, likely the sleep code was just like a couple orders of magnitude too large before or something. Or we're doing something fucking brain dead, stupid, dumb. Who knows? Oh, baby. Let's go. Let's go. So I would call that a fucking success for now. I think that is quite hype. So we have now successfully made it into Zigland. We are blinking an LED from a main loop in Zig, and there's no SDK involved. We finally fucking got there. We have the world's shittiest stupid example, but we built it up from scratch ourselves, which I think is very hype, right? So what is the process here? We have boot2.s. This guy, he copies essentially the relevant parts of the binary into RAM and just fucking jumps over there. Our start function in main.zig is literally just like, fuck it, we'll do nothing. I don't give a shit. Just call main, bro. Main does basically, we were doing like the C stuff we were doing before. We take the chip out of reset. We set the output as an output, and we just fucking like run that shit using the like stupid little ROSC clock. The ELF file we now understand kind of determines how OpenOCD will program this thing. So OpenOCD, he talks to this chip over the like software debug ports. He wiggles the bits on that thing to write, you know, chunks of the ELF file that we give it to Flash. So if we look at read ELF segments on our output binary, he basically says, yo, we're going to put the stuff on Flash at these physical addresses, and then our bootloader copies these physical addresses to these virtual addresses which represent RAM. So I think we've got kind of like the whole picture, which is pretty fucking sick. Pretty fucking sick. Thanks for watching, guys. If you like what we saw, we stream most days around 12:30 Pacific time to 4 o'clock Pacific time. It is 4 now, so anywhere between 3.5 hours ago to 30 minutes from now is when you should expect to see us live. We are working on this Pico, Raspberry Pi Pico stuff. Probably the next steps are going to be Serial and I2C. If you want to keep up with that stuff, videos of these streams will go up on the YouTube, which is linked in the Twitch description. Some videos do not make it there. It's basically based off of whether I feel like it is something that is YouTube algorithm friendly or not. Unfortunately, we do have to play that game a little bit. But if you want access to the rest of the VODs, those are behind paywalls. So on the Twitch you can sub, Patreon you can sub, YouTube you can join, and you get like whatever's left on there, which is like, you know, some stuff. Like we did a couple streams this week on creating a CRC visualizer. So we posted the CRC explanation stream video on like the main thing, but like the construction of the graphics and stuff was done in happy hour type shit. So typically it's stuff like refactoring, reading, background work, stuff that I don't think like gets titled and thumbnailed well, but is still worth doing and streaming. So if you want access to that stuff, please consider supporting on whatever platforms make sense for you. This content will end someday, right? And that day is marked by a dollar amount in my bank account. So, every dollar I make doing this extends the content by some amount of time. And so just consider it. No worries if not. Otherwise, I think we are done trying to get you guys to hand me money like fucking beggars. And I think it's time to say goodbye to YouTube and find someone to raid on Twitch.